Hi student, this is Sukumar here. Now I give introduction about Unit 1 Electrostatics. What is electrostatics? Branch of electricity which deals with stationary charge is called electrostatics. It means that electricity can be classified in two categories, static electricity and dynamic electricity. So electrostatic, it is one of the branch of electricity. Also, in this lesson, you guys studied about properties of resistant of charges. Properties of resistant of charges. Otherwise, we can say properties of stationary state of charges. Only you guys studied about in this lesson. But already studied in second lesson, current electricity. You guys studied about properties of movable state of charges, drift velocity, mobility, etc. They are properties of movable state of charges. Already you guys studied in second lesson. Properties of resistant of charges, electric field, electric potential, electrostatic potential energy, etc. They are properties of resistant of charges. Only you guys studied about in this lesson. Already you know what is meant by charge. Already you know charge related with some terms. Already you know. Next, you watch this 2 number of video corresponding to the historic.
Sometimes, if you touch a metallic doorknob or any metallic object, you might experience a mild shock. This is because the metallic object was charged, or in other words, it carried an electric charge. Objects that carry an electric charge are said to be electrically charged. We know that when a comb is rubbed against dry hair, it begins to attract small pieces of paper. When two pieces of silk cloth are rubbed against two glass rods individually, and the glass rods are kept beside each other, the glass rods repel each other. Now, if one of the silk cloths and a glass rod are kept beside each other, they attract each other. Now, bring one charged glass rod in contact with a pith ball and then separate them. Then bring the other charged glass rod in contact with other pith ball and then separate them too. When these pith balls are kept close to each other without contact, we observe that they repel each other. The physical quantity responsible for all these phenomena is known as electric charge. Electric charge can be defined as the property of matter that exhibits its electrostatic interaction with other matter. From previous examples, bodies like combs, glass rods, silk cloth pieces, pith balls, etc. are said to be electrified or are called charged bodies. The study of electric charges at rest and the physical quantities associated with electric charges at rest is called electrostatics or static electricity. These experiments prove that a body can be charged by rubbing against another body or by simply bringing a charged body in contact with another uncharged or neutral body. When the glass rod and silk cloth were first rubbed, they get electrified. But when they are brought in contact again and separated, they lose their electrification or charge and are neutralized. In other words, the charge on them is nullified. Hence, we can conclude that one of them may be positively charged and the other negatively charged when they are rubbed against each other. From these observations, we see that there exists only two types of electric charges in the nature. Conventionally, they are called positive and negative. It is also observed that the like-charged bodies repel each other. For example, two pith balls, both carrying like charges, repel each other. Unlike charged bodies attract each other. For example, a pith ball carrying a positive charge will attract a negatively charged pith ball. We know that all matter is made up of atoms or molecules. Also, within an atom, the total negative charge is balanced by the total positive charge in it. When we rub one material against another material, the material in which electrons are relatively loosely bound to its atoms readily loses a few of its electrons to the other material. The material that lost electrons now has a deficit of electrons, and hence becomes positively charged. And the one that gained electrons becomes negatively charged. In this case, the glass rod lost electrons and became positively charged, and silk gained those electrons and became negatively charged.
Topic: electric charge. How does a plastic comb attract paper? What? You don't believe me? Okay, let us try. Take a plastic comb and bring it close to some pieces of paper. Hey, wait. Don't laugh. We need to do something first. Rub the comb on your dry hair and then bring the comb close to the pieces of paper. See? I was correct. The pieces of paper got attracted to the plastic comb. Do you think it is magic? No. The reason behind this is electric charge. Electric charge is the quantity of electricity held in an object. There are two types of electric charges, positive and negative. However, there are some objects where the positive and negative charges are equal to one another. In such cases, we say that the object is electrically neutral. So, was the plastic comb initially electrically neutral or electrically charged? Initially, the plastic comb was electrically neutral. That means it had an equal number of positive and negative charges. Hence, it did not have the ability to exert a force and attract the pieces of paper. So, after rubbing the plastic comb on our dry hair, why was it able to attract the pieces of paper? I will tell you why. When we rubbed the plastic comb on our dry hair, it gained an electric charge. Once it got electrically charged, it got the ability to exert a force on the pieces of paper and attract them. This charge is called as static electricity. However, do you think, like a plastic comb, a metallic comb would also attract the pieces of paper? Nope, you are wrong. A metallic comb will not attract the pieces of paper like the plastic comb. Wondering why is that so? It is because plastic is not a good conductor of electricity. It does not allow the electric charges to flow through it onto the earth. As a result, the charges build in the plastic comb, making it electrically charged and enabling it to attract the pieces of paper. However, metal is a good conductor of electricity. It does not let the charges build in it. It allows the electric charges to flow through it onto the earth, thus not allowing the metallic comb to get electrically charged. As a result, the metallic comb does not attract the pieces of paper.
Okay, next we see about what are the basic properties of charges. First one is electric charge or charges. Second one is conservation of charges. Third one is quantization of charges. These three properties are basic properties of charges. First one is charges. Most of objects in this universe are made up of atoms. These atoms are made up of proton, neutron and electrons. These particles have mass and inherent properties of the particle. Similarly, electric charge is another intrinsic and fundamental property of the particle. The nature of charges is understood through the various experiments, previous video also you can understand. Next, second one is conservation of charges. When one of the object rubbed with another object, charges are transferred from one to other. Before rubbing, both objects are equally neutral, and rubbing simplified transfer the charges from one of the object to other. Already you follow previous video. For example, when a glass rod is rubbed against the silk cloth, some negative charges are transferred from glass to silk. As a result, glass rod is positively charged and the silk cloth becomes negatively charged. So previous video follow corresponding to this example. From this observation, he concluded that charges are neither created nor destroyed but can only transfer from one of the object to other. So this is called conservation of total charge. Second one is conservation of total charge. This one is a very important property. So next I represent into mark. This one is very important property. Next, third one is quantization of charges. Third one is quantization of charges. Any charge represented by Q is equal to NE. The charge Q on any object equal to the integral multiple of this fundamental unit of charge. Here, E fundamental unit of charge, its value 1.6 into 10 power minus 19 coulomb. You follow here. Its value 1.6 into 10 power minus 19 coulomb fundamental unit of charge E value. Next, charge of an electron minus E, it means that minus 1.6 into 10 power minus 19 coulomb. Charge of proton, charge of a proton plus E plus 1.6 into 10 power minus 19 coulomb. So next, one more important thing is when a glass rod is rubbed with the silk cloth, the number of charges are transfer is equally number of charges are transfer is usually very large, typical in the order of 10 power plus 10. So charges quantization is not appreciable at the macroscopic level. Hence the charges are treated to be continuous, not discrete. So we follow another videos corresponding to this topic. We follow another video corresponding to this topic. These three number of properties. Okay, next.
Charges are also conserved in natural processes such as the beta decay of a neutron. During the beta decay, a neutron breaks into a proton and an electron, releasing a neutrino. Here, the neutron and neutrino are chargeless particles, while the proton and electron are oppositely charged particles, whose combined net charge is 0. Hence, we observe that the total charge in this process is conserved. The charge on an object is measured as an integral multiple of the basic unit of charge that the proton or electron carries and is denoted by E. This property is called quantization of charge. The magnitude of the basic unit of charge E is approximately equal to 1.6 into 10 raised to power minus 19 coulomb. In an atom, when we refer to the charge on a proton, its value is positive and is referred to as plus E, whereas the value of E for a charge on an electron is negative and is referred to as minus E. Thus, the charge on an object Q is equal to the product of the number of electrons gained or lost by it, N, and the basic unit of charge, E.
Conservation of charge. The total charge of an isolated system remains constant during any process. Charge can be transferred from one body to another, but it can neither be created nor destroyed. For example, grounding of the charge. Quantization. Any charged body has a total charge, that is, an integral multiple of a certain smallest amount of a charge E. The smallest amount of free charge E that has been discovered is the charge on an electron or a proton having magnitude 1.60 into 10 raised to the power minus 19 coulomb. Any charge Q on an object can always be expressed as Q is equal to NE, where N is an integer.